So what we're going to do now that we can actually graph these equations, we're actually going to create the equation from word problems. Because linear programming itself is a real life application of the math that you're learning right now. And to do the word problems, to do a word problem, what we're going to do is we're going to define the variables. Generally, you have two variables because we're talking in two dimensions. Identify the restrictions, and the restrictions are going to be the equations that you're creating. And so when we start doing that, we're going to look for words like at least, which means that you're talking about if something is at least something, that is greater than or equal to it. Or you can look for words like at most. And if something is at most, I mean, it can't exceed it, so it's going to be less than or equal to. So you're looking for things like that. We're going to graph the inequalities, and then we want to find the corner points. So we're going to stop just short of what actual linear programming is in this particular thing. So here's an example. It says that a manufacturing company makes two types of water skis, a trick ski and a slalom ski. The trick ski requires 6 labor hours for fabricating and 1 labor hour for finishing. The slalom ski requires 4 labor hours for fabricating and 1 labor hour for finishing. The maximum labor hours available per day for fabricating and finishing are 108 and 24 hours respectively. So we need to define our variables. And let's define our variables as either you have a trick ski, which we'll call X, or you have the slalom ski, which we'll call Y. And what we can do is we can make a table out of this. And this table is going to help us organize what we're talking about. So notice we have X here. The X variable is sitting here. And the Y variable is sitting here. And then we have our restraints. Well, what is restraining us? So the two processes they have are fabricating and labor. We only have a certain amount of time for each one. It takes 6 labor hours to fabricate one trick ski. So we'll put in here, it takes 6 hours for that. And it takes 1 labor hour to finish that. So we'll put that in for finishing. For a slalom ski, it takes 4 labor hours to fabricate and 1 labor hour to finish. Now, the next part says that we have a maximum, which means we cannot exceed that. We have a maximum. So we can't exceed this or this. We can't exceed the fabricating or finishing time that we have. We have a maximum of 108 fabricating hours and a maximum of 24 of these. So we have our equations written here, and the equations say that 6x plus 4y has to be less than or equal to 108, and x plus y has to be less than or equal to 24. All right? And when we graph this now, we can actually graph that. The other thing we need to know is that we have to make something. So we have to make some trick skis, x greater than or equal to 0, and some slalom skis, y greater than or equal to 0. So we can graph these equations. Before we graph this, let's actually define our axis, x and y, with their actual variables. So x is a trick ski, and y is a slalom ski. And now we can actually graph these variables by rewriting the equation. So this first equation, 6x plus 4y is less than or equal to 108. I'm going to move the 6x over first, so I get 4y less than or equal to negative 6x plus 108. I'm going to divide everything by 4. When I do that, I get y less than or equal to negative 3 over 2x plus 27. So to plot that, I'm going to plot 27, and this has to go down 3 over 2. Down 3 over 2. One, two, three, 1, 2. 1, 2, 3, 1, 2. So here's the line I get for that. And this is my fabricating line. And I have to be less than that, so I'm going to shade below this. So when I look at my next one then, I'm doing x plus y is less than or equal to 24. So x plus y less than or equal to 24, which is just y is less than or equal to negative x plus 24. So plot 24, down 1 over 1. So if I go down 1 over 1, the reason that we have to make sure that our lines are pretty accurate is because if you notice mine right now looks like it's crossing at 2 points. So I have to go back and then redo that green line again to make sure I can get where it's going. It looked like it intersected at 2 points. I'm pretty sure it's only intersecting at 1. So I'm going to go ahead and draw this again. And I'm going to actually use the line tool on my actual iPad here. Let's do that again. I don't want to do that like that. We'll just do it like this. And again, this one's going to be shaded below this line. So I'm shading below, again, the purple line. I'm looking for the intersection of the 2 points. I'm looking for corners. So I see a corner sits here. The corner sits here at 0, 24. It looks like this point is the intersection. At the point, I'm going to say 518. It might actually be 1 over at 419, but just keep in mind that's what we're trying to get there. And then this one will be at 18, 0. They're your corners.